Good morning, guys. So today we will discuss a rational equation. Last time also we solved I think like a couple of problems, right? So here let's do this one, okay? This one. So if you want to solve this, this is a rational equation because it consists of rational expressions, right? So 3x plus 2 over x minus 2. So that is a rational expression, right? You have a polynomial in the numerator and polynomial in the denominator, right? It's 3x plus 2 over x minus 2, 1 over x, and negative 2 over x squared minus 2x. They are a rational expression, right? And this equation consists of rational expressions. So that's why this is a rational equation, right? So now if you want to solve this equation, so you see we have a 3x plus 2 over x minus 2 plus 1 over x equal to negative 2 over x squared minus 2x, right? So now you need to find, now first of all, you see this equation can be written as you have a 3x plus 2 over x minus 2 plus 1 over x, and this equals to negative 2 over, hey, how can you factor out this? So how do you factor out x squared minus 2x? Or what are the factors of x squared minus 2x? Can you factor out x, right? Then what should be the inside the parenthesis? So you have x minus 2. Is that right? So this is x times x minus 2. Did you see that? Yes? So now you need to find the LCD, least common denominator. What is the LCD? What is the least common denominator of x minus 2, x, and x times x minus 2? So how do you find the least common denominator? So look here, the factors of x minus 2 is x minus 2, right? And the factor of x is x itself. So now you find out the common factor. You find out the common factor. So you can take common between 2 also here, okay? So now if you look here, this x minus 2 and x minus 2 common. Is that right? Right? This x minus 2 is common here. And what are the, and then you see this x and this x is also common. Are you with me? Right? So now this, and there are no remaining factors, right? This x and x common here, and x minus 2 common here. So now the LCD is going to be x times x minus 2, right? Now you multiply both sides of the equation by x times x minus 2. So you multiply this by x times x minus 2 times 3x plus 2 over x minus 2. You multiply this by x times x minus 2 times 1 over x, and this equals to, you multiply right hand side by this LCD, okay? So what will be that is? So it would be x times x minus 2 times negative 2 over x times x minus 2. Did you get it? Right? First, you need to find the LCD. Okay? And then you need to multiply both sides of the equation by LCD. Now, what is the purpose of multiplying both sides by LCD? You see what happened here? What is this? X minus 2, right? What is this? X minus 2, right? You see x minus 2 on the numerator and x minus 2 on the denominator. So what can you do? Can you cross them out? Yes? And similarly here, this x and x, you can cancel them, right? And here, this x and x, x minus 2, x minus 2. Did you see that? Now you get rid of the what? You got rid of the denominator. That makes sense? So that is the purpose of what? Multiplying both sides by LCD. Okay? So now, what will be here, guys? So you have an x here, x times 3x plus 2 plus, and you see the x minus 2 here, right? X minus 2, and then equals to, what is that is? Negative 2. You got it? That makes sense? Okay. So now you distribute this x, okay? So what is x times 3x? 3x squared. Yep, 3x is squared. What is x times 2? 2x. And this is positive, right? So positive times x is positive x. This is negative 2 equal to what? Negative 2. Right? Make sense? Now, this is going to be 3x squared plus, you combine 2x and x, so this is 3x minus 2 equal to what? Negative 2. Okay, so now you add 2 on both sides, okay? So you do plus 2 and plus 2 here, is cross them out, and this also, you can cancel negative 2 and positive 2, right? So now, what do you have here? 3x squared plus 3x equal to 0, right? And then, how do you solve? This is a quadratic equation, right? How do you solve it? Can I factor out 3x? Yes? If I factor out 3x, it's going to be x plus 3 equal to, no, sorry. If I factor out 3x, what will be here? X plus 1 equal to 0, right? And then you can divide both sides by 3. You cancel them, right? So now it would be x times x plus 1 equal to 0. And then you use zero factor property, right? So if you look here, x times x plus 1 equal to 0, either x equal to 0 or x plus 1 equal to 0. Make sense? So x plus 1 equal to 0 will give you x equal to negative 1. Now these are the proposed solution. Okay, but now you see these values of x does not make the denominator 0. What is the value of x that makes the denominator 0? What value of x makes the denominator 0? 0, right? So if you have a value of x 0, it makes the denominator 0, then 1 over 0 will be what? Undefined. Is that right? And what is the other value of x that makes the denominator 0? Hmm? 2. If you plug in 2 here, what will happen? 2 minus 2? 0. Is that right? If you plug in 2 here, what will happen? 2 minus 2, 0. So now, 0 and 2 cannot be the solution to the equation. Is that right? So now that means this x equal to 0 is not a solution. Are you guys with me? Right? If I plug in x equal to 2, what makes the denominator 0? You know, the value of x equal to 2 and value of x equal to 0 makes the denominator 0, right? So that means 2 and 0 cannot be a solution, right? So we got the value of x equal to 0. So this 0 is not a solution. So now the solution must be what? -1. Did that make sense? Yep. Okay. You see that? Now for this one, we follow the same similar method. You know, first we find the LCD, least common denominator, right? And we multiply both sides of the equation by least common denominator. Do you know what is the LCD? Look here, guys. So what do you have? You have a negative 4x over x minus 1, and you have a plus 4 over x plus 1 equals to negative 8 over x squared minus 1, right? So what are the factors of x squared minus 1? Can you factor it, x squared minus 1? You know a square minus b square, right? What is a square minus b square? Difference of squares. Huh? You got, a plus b times a minus b, is that right? Right? You see that? So now here x squared minus 1 is same as x squared minus 1 square, right? So what are the factors of x squared minus 1 square? X plus 1 times x minus 1, right? Okay. And then you see the factors of x minus 1 is x minus 1 itself, and the factors of x plus 1 is x plus 1 itself, right? Did you get it? And now you find out the common factors. So what are the common factors? You see x plus 1 here, see that? And x plus 1 here. So you can factor out x plus 1. This is the common factor, right? And then, similarly, if you look here, you have x minus 1 here, and x minus 1 here. So the x minus 1 is common, right? So you don't have a remaining factors. I mean, like you have a 1, but, you don't have to write that, right? So this is your what? LCD. Does that make sense? Are you guys with me? Yes? So now you multiply both sides of the equation by LCD. So if you want to multiply both sides of the equation by LCD, you have what do you have over there? So negative 4x over x minus 1, right? So x plus 1 times x minus 1 times negative 4x over x minus 1. So I multiplied the first rational expression, right, by LCD. So do the same thing here. So you have x plus 1 times x minus 1 times 4 over x plus 1. 4 over x plus 1. Good? And this equals to now x plus 1 times x minus 1 times negative 8 over, what do you have? X square minus 1. You know the x square minus 1. What are the factors of x square minus 1? This is equal to x plus 1 times x minus 1, right? So I can write down here x plus 1 times x minus 1. Make sense, guys? Yes? So now, look here. What happened here, guys? You see the x minus 1 in the denominator and in the numerator. You can cancel them. And same thing here, this x plus 1 and x plus 1. You can cancel them. And then x plus 1, x plus 1, x minus 1, x minus 1. You can cancel them. Okay? So now, what do you have here? You have x plus 1 times negative 4x plus you have x minus 1 times 4 equals to what? Negative 8. Right? So now you distribute this negative 4x, okay? You can this is same as negative 4x times x plus 1. Is that right? Because they commute, right? They commute, this is, a times b is same as b times c. You know that, right? Commutative property right now. So negative 4x times x plus 1 plus this is same as 4 times x minus 1 equal to what? Negative 8. Is that right? Okay. So now, can we distribute this? What is negative 4x times x?
Negative 4x squared.
Yep. Negative 4x squared. What is negative 4x times positive 1? Negative 4x, is that right? And then what is 4 times x? 4x. This 4 times, this is positive 4, right? Positive 4 times negative 1 is negative 4, right? Equal to negative 8. Does that make sense, guys? Yes? So now, what you can do here is this negative 4x and positive 4x, you can cancel them, right? So what do you have? Negative 4x squared, negative 4 equals to negative 8. And you add 8 on both sides. So you have a negative 4x squared. Negative 4 plus 8 is positive 4 equals to, this is 0. And you see you can factor out negative 4, right? From here you can divide by negative 4, it's the same thing. So you factor out negative 4, let me write down here. So if you factor out negative 4 from here, okay? If you factor out negative 4, then you'll have x squared minus 1 equal to 0. Right? Then you divide both sides by negative 4. So you cross them out. And now what is x squared minus 1? Or you can simply do like this. You guys know x squared minus 1 equal to 0. So that will give you x squared equal to 1. Is that right? Right? Remember the square root property? If you have x squared equal to k, if x squared equal to k, then x equal to what? Plus or minus radical k. Remember that? So that will give you x equal to plus or minus 1, or positive 1 and negative 1. Now, you see, if you look at the denominator, what cannot be the value of x? what value of x cannot be the solution to this equation? Or what value of x makes the denominator 0? 1. And if you plug in 1, it will be 0. So something over 0 is undefined, right? So x equal to 1 cannot be a solution, right? Now what value of x makes x plus 1 0? Negative 1. You see that? So the positive 1 and negative 1 both cannot be a solution. So that means this rational equation does not have a solution. No solution. Okay? So that will give you no solution. Or people, they denote like this. You see that? That means no solution. You got it? Huh? Yeah. That makes sense, right? So the solution set is, this equation does not have a solution. The solution set is denoted by this phi. It is read as, you read as phi. Okay. So now can you read this? You know, like if a job can be done in t units of time, then the rate of work is 1 over t. The R is the rate of work, is 1 over t of the job per unit time. And the amount of work completed is rate of work times amount of time worked. So what you need to know here is, guys, this, okay, if a job can be done in t units of time, okay, you have a, let's say, job, one job, that, if a job means, what you need to know is if a job, so that means if one job, a job means what? One job, is that right? If one job can be done in t units of time, can be done in t units of time, then the rate of work, which is denoted by R, okay, the rate of work which is denoted by R is 1 over t of the job per unit time. 1 over t of the job per unit time. So this is now the rate of work R is 1 over t. Okay, and then what you need to know is if A is the amount of work, it's going to be rate of work times t. So t is the amount of time worked. Okay, so where A is the amount of work done or completed, whatever. Amount of work done, A is the amount of work done, right? And R is the rate, right? Rate of work. Are you guys with me? So this is the rate of work, and T is the time, right? The amount of time worked. So this is the amount of time worked. It's something like, you remember, like D equal to RT, D is the distance, R is the rate, and T is the time. You remember that? It's similar to that one, right? This R is the rate of work, and T is the amount of time worked, and A is the amount of work done or work completed, whatever. You got it? So now look here, guys. So you have a one printer, right? So look here. One printer can do a job twice as fast as another. Working together, both printers can do the job in 2 hours. How long would it take each printer working alone to do the job? So how do you solve this problem? So you need what? Like first you read the problem, right? Assign the variable, right? And set up the equation, right? And then solve it. Okay? So now let's work. First, can you read this? So what did you understand? Like, you see the one printer, right, can do a job twice as fast as another one. Is that right? So how do you do that? Working together, both printers can do the job in 2 hours. How long would it take each printer working alone to do the job? Any idea? So, did you understand the problem? We have a two type of printer, right? One is fast, another one is slower. Is that right? The fast printer can do a job twice as fast as the what? Slower printer, right? So now let's assign the variable. So you have a two type of printer. One is a faster. You have a faster printer, and you have a slower printer. So I will assume let X represent the number of hours. Let X represents the number of hours faster printer, right? Number of hours faster printer so let X represent the number of hours faster printer take to do the job working alone. Does that make sense? Are you guys with me? Right? Let X represents the number of hours faster printer takes to do the job working alone. So if you read the question, guys, one printer, the faster printer, can do a job twice as fast as another printer. Is that right? Twice as fast as slower printer. Is that right? So now, how long does it take for the slower printer to complete the job working alone? We suppose the faster printer takes X hours to complete the job working alone. Is that right? So how many hours does the slower printer? 2x. Exactly, 2x. You see what I'm talking, right? Because if the faster printer takes X hours to complete the job working alone, right, then the slower printer will take what? 2x hours. You know why? Because faster printer can do the job twice as fast as the what? Slower printer. Does that make sense? So now, if that is the case, then you can say that the slower printer takes 2x hours to do the job, to complete the job, working alone. To complete a job working alone. Did that make sense? Right? Now, what you need to know is the amount of work completed is what? Rate of work times amount of time worked. Is that right? So this is you have to use this formula. This is rate. This is time, right? Amount of time worked. And this is the what? Amount of work completed. Make sense? So let me make a table here, okay? So what you have here is rate, which is denoted by R, and then we have time, amount of time worked, we denote it by T, and then we have the part of the job completed, right? Part of the job completed, okay? Are you guys with me? We have two types of printer. One is faster and another one is slower. Okay, guys? Did you see that? Oh. Right? So now, what is the rate? You see, remember rate is 1 over T. Right? Per unit time. Is that right? So now, you see, how long does the faster printer work? X hours, is that right? The faster printer takes X hour to do the job, means it is the one job, okay? Just be very careful, okay? This to do a job, okay? So the rate for the faster printer, okay? So the rate for the faster printer, this is for the faster printer, okay? The rate for the faster printer is going to be 1 over X, because the faster printer work X hours to complete one job. Is that right? You remember that, right? Look here, guys, I'm talking about this, you see. If a job can be done in T units of time, what is the rate of work? 1 over T. Is that right? So now here, a job can be done by faster printer in X hours. Is that right? So the rate is going to be what? 1 over X. So this is the rate for the faster printer. Did you say that? Yes? Right? And now what will be the rate for the slower printer? For the slower printer,
1 over 2x.
Exactly, yep. Good job. So this is going to be 1 over what? 2x. So this is for the faster, this is for the what? Slower, okay? So now the faster printer, the rate is 1 over X. For the slower printer, the rate is going to be what? 1 over 2x. Did that make sense here? Right? And then, so how long? So what is the amount of time worked for the faster printer? And you see in the question, if you remember in the questions, they worked, both of them worked for 2 hours. Is that right? Remember? Working together, both printers can do the job in 2 hours. Did you see that in the question? Working together, so you have to understand this. Working together, both printer can do the job in 2 hours. So that means the faster printer works for 2 hours and the slower printer, it also works for 2 hours. Did you see that? Right? And then the part of the job completed by faster printer is the rate times time. You see that? The amount of work completed is what? R times T. Is that right? So you multiply 1 over x by 2. So 1 over x times 2. This is rate times amount of time worked, which is 2. So this is going to be 2 over x. And here 1 over 2x times what? 2. So that will be, you see this 2 and 2 cancel. You can write 2 over 2. Yeah, this 2 to cancel, right? So you'll have 1 over x. Did you see that? Yes? Yes? Okay. So, but both printer, if they work together, they complete one job. Is that right? If they work together, they will complete a job. Means what? One job. Is that right? So this is the part of the job completed by faster printer. This is the part of the job completed by slower printer. If you add them up, that must be equal to what? One work. Is that right? So now, this 2 over x plus 1 over x must be equal to what? 1. You see what I'm talking about? Okay. So now, you see they have the same common denominator. You can simply write down this is 3 over x equal to 1. Is that right? Right? And then you do the cross multiplication. This is x equal to what? 3. So the value of x is 3. So that means the faster printer takes 3 hours to complete a job working alone. Does that make sense? And the slower printer takes 2 times 1, which is 2. Is that right? 2 hours, right? To complete a job working alone. Did I make sense? So now the faster printer can take 1 hour. Sorry, 3 hours. I'm sorry, guys. Faster printer takes 3 hours to complete a job working alone. Working alone. And slower printer takes, right? Does that make sense? 2x hours means 2 times 3, which is what? 2x means 2 times 3. 2 times 3 is what? 6 hours. Is that right? 6 hours to complete a job working alone. Okay. I think you got it, right? Yeah. So now we will try to solve the radical equation, okay? The equation contains radical, okay? So radical equation means like an equation that contains what? Radical term. Like square root of x, cube root of x, something like that, right? And generally, to solve the radical equation, we follow these steps, right? So the number one is isolate the radical on one side of the equation. So let me work with the problem. So it will be, now look this equation, okay? So okay. So you have x minus radical 15 minus 2x equal to 0. Right? So this is a radical equation. Why? Because this equation contains radical term. Is that right? And then what is the first step? You isolate the radical term on one side of the equation. That makes sense? So now it's up to you. You can keep this on the left side, this radical term on the left side, or you can move this to the what? Right side. What do you want to do? Do you want to keep this on the left side or you want to move to the right side? You have to isolate this. Right side? So if you want to move this to the right side, you add radical 15 minus 2x on both sides. You do that. Make sense? Right? And then you cross them out. So now that will be x equal to radical 15 minus 2x. You have this, right? So now, you see, if you have you need to get rid of the what? Radical sign. How do you get rid of the radical sign? So how do you get rid of this square root sign? If you have a square root sign, you square on both sides. Okay? You square on both sides like this. If you have a cube root, raise to the power 3 on both sides, of the cubing on both sides. Does that make sense? You see what I'm talking, right? Let's say for example, okay? So if you have a cube root of x equal to 3, how do you get rid of this radical sign? This is also the radical sign, right? Cube root, right? Right? What you are supposed to do? Raise to the power 3 on both sides. That makes sense? And then its cube root of x raised to the power 3 is x. And this 3 cube is, 3 times 3, 9 times 3, what? 27. This is the. But here you have a square root sign. This radical term. So you square on both sides. You square on both sides. So now, what do we here? So it would be x square, and what is this? Radical 15 minus 2x square. What is this?
Would be 15 squared minus 2x squared?
Not really. So when you square the radical like a square root term, then the square root sign will be gone. Okay? So it will be only 15 minus what? 2x. That makes sense. So this is like, I mean, again, let me explain why that happened. Look here. So if you have a square root of x, if you square this, look here, this square root of x is x to the power 1/2. Because you know that if you have nth root of x, this is x to the power what? 1 over n. This is square root of x is x to the power 1/2. And then you raise to the power what? 2. And remember the property, the law of exponents, right? When the power is raised by power again, you multiply them. You see the power, this exponent 1/2 is raised by exponent 2. Is that right? Right? So you multiply them. So this is x, 1 over 2 times 2. This is x to the power 1 over 2 times 2 is 1, right? 1/2 times 2 is 1, right? And this is what? X. So what did you observe here? If you have a square root sign, if you square, then the radical sign will be gone. That makes sense? Okay. So now, let me write down this in a standard form, okay? So this is, you add 2x on both sides. You cross them out, right? So that is going to be x squared plus 2x equal to what? 15, right? and then you move this 15 to the left side. So you subtract 15 from both sides. You subtract 15 from both sides, you cross them out. So it will be x squared plus 2x minus 15 equal to 0. Okay, so now you can factor x squared plus 2x minus 15. So what are the factors of negative 15 so that the sum is positive 2? What are the factors of negative 15 so that the sum is 2?
5, -3.
Exactly. So you are absolutely right. 5 and negative 3, right? So I can do x plus 5 times x minus 3 equal to 0. Right? So you use the zero factor property, either x plus 5 equal to 0 or x minus 3 equal to 0. So that will give you x equal to negative 5, and that will give you x equal to 3. You got it? So now you have to plug in back those values of x in the original equation. You have to check whether these values of x satisfy the given equation or not. You have to check that. So now let's do checking for x equal to negative 5, okay? So if I plug in negative 5, so what is my original equation? So I have a x minus radical 15 minus 2x equal to 0, okay? So now let me plug in x equal to negative 5. So this is negative 5 minus 15 minus, what is that is? 2 times negative 5 equal to 0. So I want to check this. Right? Are you guys with me? So let's simplify this. So this is 15, negative times negative positive, so 2 times 5 is 10 equal to 0. Question mark. Right? So now you have this is negative 5 minus, hey, this is what is 15 plus 10?
25.
What is radical 25? 5. Negative 5 equal to 0. What? So if you look here, negative 5, when you combine, it will give you negative 10. Negative 10 equal to 0. This is false, is that right? This is false. Right? So now this is not a solution. This is not a solution. So now let's check for x equal to 3. Okay? So now you plug in x equal to 3, so 3 minus, so this is 15 minus 2 times 3. Are you guys with me? I just plugged in, the value of x equal to 3, right? So this equal to 0, question mark, right? And so it would be 3 minus, so this is 15 minus 2 times 3 is 6 equal to 0. So this is 3 minus, this is radical 9 equal to 0. So this is 3 minus 3 equal to 0. Hey, what is 3 minus 3? 0. 0 equal to 0. So this is true. Make sense? Yeah. So now this is a solution. So the solution said is this. This is the final answer. Make sense? Okay, we did it, right? Yeah. Now if you have a equation that contains 2 radicals, okay? Although let me copy that, okay? So you have solve radical 2x plus 3 minus radical x plus 1 equal to 1. So now in the previous problem, if you remember, we only have one radical term, right? And then we isolate, we keep that on one side, right? Right, but here we have a 2. So that means you have to keep one on one side and the other one to the other side. That makes sense? So now, hey, I want to keep this on the left side. Are you with me? We have a 2 radical term here, right? So that means you have to keep one on one side. If you want to keep this on the left side, you have to move this to the what? Right side.
So it doesn't matter which one you move as long as one one's on the other side?
Yeah, it doesn't matter. You can keep this on the left side and you can move this to the right side. So I want to move this to the right side. So this is plus radical x plus 1 plus radical x plus 1. And this, you cross them out, right? So what would be this? It is going to be 2x plus 3 equals to 1 plus radical x plus 1. Good. And then you have a square root, a radical term here is square root, right? So to get rid of this square root, what you are supposed to do?
Square root.
Exactly, square on both sides. Square on both sides. So that means you square this and you square this. That makes sense, right? So now, hey, what is this, guys? Radical 2x plus 3 square. Yep. Good job. This is 2x plus 3. Now, what is this? So how do you simplify this? 1 plus radical x plus 1 is square. That's close. Not exactly.
Would it be 1 plus x plus 1? Like, since 1 squared is still 1.
So if you do a plus b square, okay, what is this? What is this?
That's a plus b, like parentheses a plus b, and then parentheses a minus b.
Parentheses a plus b times a plus b. Is that right?
Yeah.
Right? You do the same thing. Okay, so now you have a 1 plus radical x plus 1 is square equal to 1 plus radical x plus 1 times 1 plus radical x plus 1. Right? Right? And then you use the FOIL. You FOIL, okay? So what is 1 times 1? 1, right? See that? So this 1 times 1 is 1. What is 1 times radical x plus 1? Radical x plus 1. Are you guys with me? Yes? What is radical x plus 1 times 1? What is radical x plus 1 times 1? Is radical x plus 1, right? Right? Now what is radical x plus 1 times radical x plus 1? So let's say, hey, this is A. So what is A times A? If you have A here, what is A times A? A square. Now this is A square. So but in place of A, what do you have? Radical x plus 1, is that right? So this is what? Radical x plus 1 square. Does that make sense? Okay? Okay? So now it would be, so this is 1 plus, now can you combine this? What is radical x plus 1 times radical x plus 1? What is a plus a? 2a. What is radical x plus 1 plus radical x plus 1? 2 times radical x plus 1. So now look here, guys. So you know a plus a is 2a. X plus x is 2x. So you say if you have a radical x plus 1 plus radical x plus 1, this is 2 times what? Radical x plus 1. That makes sense? So now this is 2 times radical x plus 1 and plus, and you know this, right? Because you have a radical square, right? So that means the radical sign will be gone, right? So this is x plus 1. So now it will be 1 plus, so 1 plus 1 is 2, 2 plus 2 radical x plus 1 plus x. That makes sense? This 1 and 1 is 2. This is 2 radical x plus 1 and plus x. This is x. Did you get it? Okay, so now let me write down here. This is 2 plus 2 radical x plus 1 plus x. Right? So now, how many radical term you have now? Only one, right? Right? So we need to isolate. We need to keep this on right side. You have to move this to the left side. Does that make sense? So you subtract 2 from both sides and you subtract x from both sides. Are you guys with me? Right? Cross them out. Cross them out. Okay? So now, so what is 2x minus x? X, right? What is 3 minus 2? 1. Equals to, you have a 2 times radical x plus 1. This 2 times this here. So you have a square root. Radical x plus 1, right? We need to get rid of this radical sign, right? So how can you get rid of the radical sign? You need to square on both sides, right? Right? So now you square on both sides. So you square here, you square here. That makes sense? So now you have x plus 1 is square. And what is x plus 1 is square? Is x plus 1 times x plus 1. And this equal to, hey, what is this, guys? This is 2 radical x plus 1 is square, right? So what is 2 is square? What is 2 is square? What is 2 is square? 2 times 2, 4, right? So this is 4. And what is radical x plus 1 is square? You know that, right? If you have a times b square, this is same as a square b square. Is that right? So now this is same as 2 square times radical x plus 1 is square. And the 2 square is 4. Radical x plus 1 is square is simply what? X plus 1. Does that make sense? So now you use the FOIL. X times x is x squared plus x times 1 is x plus 1 times x is x plus 1 times 1 is 1. You distribute this 4, okay? You distribute. So it would be 4x plus what? 4. Make sense? So now it will be x squared plus 2x plus 1 equal to 4x plus 4. Right? This is a quadratic equation. And now you move this to the left side, okay? Right? Let us write down the quadratic equation in standard form. You know the standard form, right? ax squared plus bx plus c equal to 0. So now it will be negative 4x, and this is negative 4, and here this is negative 4. Okay? So it would be x squared. Wait, what is 2x minus 4x? What is 2x minus? Yes, good job, negative 2x. And what is 1 minus 4?
Negative 3.
3. And this cancel and this cancel. Is that right?
Yes, sir.
So you have a right hand side 0. Now this is a what? Quadratic equation in standard form. Okay? So now, hey, how do you factor this, guys?
1 and negative 3.
Yes, 1 and negative 3, right? So this is x minus 1 times, no, x minus 3 and x plus 1 equal to, is that what you said?
Yes, sir.
Okay, good. So now you have x equal to 3 or x equal to negative 1. Agree? Right? So you have to check, okay? So you have to, so your original equation is radical 2x plus 3 minus radical x plus 1 equal to 1. So let's check for x equal to, checking for x equal to 3. Okay, so if we plug in x equal to 3, so that will be 2 times 3 plus 3 minus, so this is 3 plus 1, right, equal to 1. So let's see what will happen. What will happen? Are you guys with me? So now, hey, 2 times 3 is 6. 6 plus 3 is 9. So this is radical 9, right? Minus, this is radical 4, equal to 1. Right? So now what is radical 9? 3. What is radical 4? 2. Equal to 1. So what is 3 minus 2? 1 equal to 1, which is true. So this is good. Right? So now we follow the similar procedure. We plug in like x equal to what? Negative 1, okay? We got negative 1. So x equal to negative 1. So this will be negative 1. Are you guys with me? Right? You plug in x equal to negative 1. So it will be negative 1. Make sense? And now, hey, what is 2 times negative 1? Negative 2. Negative 2 plus 3 is what? 1, right? So this is 0. Is that right? Because negative 1 plus 1 is 0. And this is 1 minus 0 equal to 1. 1 equal to 1. This is also true, right? Right? So now the solution set is negative 1, comma 3. I think. So far, so good. Yeah. Right? We did it. So this is the cube root. You know, like for the cube root, you just raise to the power 3 on both sides. Let's see. It's simple. So you have a cube root of 4x squared minus 4x plus 1, right? You need to solve cube root of 4x squared minus 4x plus 1 and minus cube root of x equal to 0, right? So you remember, it also has 2 radical terms, right? So now you have to keep 1 on one side and move other to the other side, right? So now, hey, I want to move this to the right side. Is that okay for you? So you do like a plus cube root of x here. And this is also cube root of x, okay? I add cube root of x on both sides. You cross them out. So now what I have here, cube root of 4x squared minus 4x plus 1. And that is equal to cube root of x.
Once you cube both sides now to get rid of the... Right.
Yes. We raised to the power 3, or we cube on both sides, okay? Cubing on both sides, okay? So you are absolutely right, okay? That makes sense? And then when you, this is the cube root, right? And when you raise to the power 3, so you will have 4x squared minus 4x plus 1 here. And what will be on the right side? X. You got it, right? So now, hey, this is a quadratic equation, right? But let me write down in a standard form, okay? So how do you do that? You subtract. You subtract x from both sides. You cross them out. So that will be 4x squared minus 5x plus 1 equal to 0. Right? 4x squared minus 5x plus 1 equal to 0. Now, so how do you factor this, guys? How do you factor this? You have a 4x squared minus 5x plus 1 equal to 0. You multiply 4 and 1. Is that right? So what will be that is? 4. Is that right? You find the factors of 4 so that the sum is -5. Right? Right? What are they? Yes, -4, -1. If you multiply them, give you 4, right? -4 times -1 is positive 4. If you add them up, this is -4 minus 1. Is that right? -5. Good. That makes sense? Okay, so now it would be. Now be very careful. You cannot do this, okay? X minus 4 times x minus 1 equal to 3. You cannot do that. You know why? Because the coefficient of x squared is what? Other than 1. Are you with me? Because now look here. This, if you multiply this, it is not equal to this. Look here, x times x is x squared, x times -1 is -x, -4 times x is -4x, -4 times -1 is positive 4, right, equal to 0. Now x squared minus 5x plus 4 equal to what? 0. So, but this is what? 4x squared minus 5x plus 1 equal to 0. So you can do this like this if coefficient of x squared is 1. Like if you want to factor this, you can do this. Right? Did that make sense? Okay. So now what you need to do is, so this is 4x squared, and you split. You rewrite -5x, I just sum up -4x and -x. So -4x minus x plus 1 equal to 0. Is that right? Good? So now, hey, from the first two terms, what can you factor out?
4x.
Yes. So you factor out 4x. What will be inside the parenthesis?
X minus 1.
Yeah, x minus 1, okay. And then from the last two terms, what can you factor out? -1, right? From the last two terms, what can you factor out? -1. So you'll have x minus 1 equal to what? 0. Right? So now, again, you see this x minus 1 and x minus 1, you can factor out. This is common factor, right? So you factor out x minus 1, and you have a 4x minus 1 equal to 0. So you the zero factor property, right? So it's going to be x minus 1 equal to 0 or 4x minus 1 equal to 0. So this will give you x equal to 1, and this will give you x equal to 1 over 4. Agree? And then now you plug in here, guys. You have to, you plug in here. If you plug in 1, so this will be 4 minus 4 cancel 0. This is 1 cube root of 1 minus cube root of 1. This is good. For this one, is a little bit more work. Maybe they did that. I'll show you that one, okay? So 1 is good, right? 1 is good. Both are valid solution, okay? Yeah. Both are good. So 1, comma. So the solution set is 1 over 4, comma, 1. Right? So this is 1 over 4, comma, 1. Makes sense? So, hey, if you want to solve this equation, you see that x to the power 3 over 5 equal to 27. How do you solve this? X to the power 3 over 5 equal to 27. You need to solve it. Any idea? Do you know how to do it? No? I mean, like, there are so many ways of solving this equation. I think I can do, like, let's say raised to the power 1 over 5, okay? So this is a fifth root of x cubed. This is same as fifth root of x cubed. So raised to the power 5 and raised to the power 5. I can do that. Because this is, you see, x to the power 3 over 5 is same as x cubed raised to the power 1 over 5 is same as fifth root of x cubed. Are you with me? You know that, right? So now that's why I raised to the power 5. So if I raise to the power 5, you see, hey, x to the power 3 over 5 times 5. Is that right? The exponent, the power is raised by power again. You multiply them. And on the right side, you have a 27 to the power 5. So what is 27 to the power 5, guys? This 5 cancel. Right? So now this is x cubed equal to what? 27 to the power 5. What is 27 to the power 5? Can you let me know? Huh? I got like a 1, 4, 3, 4, 8, 9, 0, 7. Right? Okay. So now, so this is, let me copy it right down here. So this is 1, 4, 3, 4, 8, 9, 0, 7. Right? And then you raise to the power, you see this x cube equal to this, right? So now you raise to the power 1/3. This raised to the power 1/3, okay? So it will be raised to the power 1/3. So what did you get, guys? You raise to the power 1 over 3. Oh, let me show that. So I can show you here, right? Let me do it down here. Okay, I want to stop here, guys. I'll see you later, okay?